Our topic for today is about scale factor. Let's look at the examples. So this is example number 1. I have here a rectangle with dimensions 1 and 2. For my figure A prime, I have increased this side and made it into a 2, and the 2 became a 4. So the first question is, what factor did you use to get from 1 to 2 or from 2 to 4? If your answer is 2, then very good. You have found the scale factor. So that is what you're using to multiply it by. For our example number 2, still rectangles, this side is 3 units and this side is 6 units, and it became this. So it became 1 and this became a 2. So let's look at this. What factor have we done or used to get from 3 to 1? So from 3 it became a 1, and from 6 it became a 2. Very good. We have used a scale factor of multiplying it by 1/3. So scale factor may be dilating it to make it bigger or dilating it to make it smaller. This may also be expressed in ratio form, and in this case, this is 1:2. So from 1, you have increased the side to 2 units, and in this particular case, it's 1:1/3, meaning from this side, it became smaller by 1/3, and we're talking about the measurement of the sides. How does the scale factor affect the perimeter of a certain figure? So in the case of figure A, the perimeter of figure A is 6 units and the perimeter of figure A prime is 12 units. As you can see, the ratio of 1:2 was applied as well. So if the scale factor, as we said, was a 2, then for the perimeter, it will just be multiplying it by 2 as well to get to the prime. Let's look at how the perimeter of example number 2 has been affected by the scale factor of 1/3. If you would look at it, figure B has a perimeter of 18 units. Figure B prime has a perimeter of 6 units. The way to get from 18 units to 6 units is by multiplying the scale factor of 1/3, or by dividing figure B by 3, and then you're going to get B prime by doing so. So the next question is, how is area affected by the scale factor? So here the scale factor is 2, and I want you to observe what happens to the area of figure A. Figure A's area is 2 square units, while figure A prime's area is 8 square units. If you would take a look at it, what you did to go from 2 square units to 8 square units is you have multiplied 4. That 4 actually came from the scale factor of 2 from the sides squared. So with that said, let us take a look at example number 2. The area for figure B is 18 square units, so 6 times 3 is 18. And the area for figure B prime is 2 square units, and that's 2 times 1. If we take a look at how we got from 18 to 2, we will realize that we're following the same principle as what we did with our example number 1, which is to get the scale factor and to square it. So let's try that. If I get my scale factor of 1/3 and I square it, I will end up having 1/9. So let's see. Is 2 1/9 of 18? Or do I have to multiply 18 by 1/9 to get the 2? Or do I have to divide 18 by 9 to get the 2? And the answer to all those questions is a yes. Therefore, I want you to remember that when it is area we're talking about, the scale factor is still being used, but you need to square it. Our next question is, how is volume affected by the scale factor? So let's look at this figure C. Is this side is 1, this is 2, and that's 3. This side is now 2, this is 4, and this is 6. So you can tell that the scale factor that you used is 2. What you did was you multiplied 1 by 2, it became a 2. 2 by 2, it became a 4. 3 by 2, and it became a 6. So let's examine this. The volume of figure C is 6 cubic units. The volume of figure C prime is 48 cubic units. So what happened? What you did was you took your scale factor of 2, and since this is now volume, you have cubed it, meaning to say this is now going to be an 8, because 2 times 2 times 2 is 8. So let's examine. So if this is 6, the way to get to my figure C prime is to multiply 6 by the factor of 8. So when you multiply 6 by 8, it's going to turn to 48. So that's how we got from 6 to 48. We took the scale factor, we cubed it, and we used that number to multiply it by. Let us look at one more example involving volume. These two figures are not drawn to scale. So figure D has 3, 6, and 9, and figure D prime has 1, 2, and 3. You can tell the 3 went from 1, the 6 went to 2, and the 9 became a 3. So you can tell that your scale factor is 1/3. What you did was you'd have to multiply the dimensions of this figure into 1/3 to get to the dimensions of the next figure. So how is the volume affected by this? Let's examine. The volume of figure D is 162 cubic units. How did I get that? Length times width times height. So 3 times 6 times 9 will give you 162 cubic units, while D prime's volume is going to be 6, coming from 1 times 2 times 3. So how is the principle of scale factor affected or affects the volume? So let's look at this. What you do is you take the scale factor, which is 1/3, and you cube it. So this is going to end up being 1/27. 1 times 1 times 1 is 1. 3 times 3 is 9 times 3 is 27. This now becomes what you will multiply by 162 to get to 6. So let's try that. 162 times 1/27 gives you exactly 6. And that's how you get to the other figure, D prime. Last and final note before we leave this topic. The effect of scale factor on area or volume depends upon the number of dimensions being changed. In all the examples I gave you, when it was volume, I changed all the 3 dimensions. When it was area, I changed both length and width dimensions. Just to put in emphasis, the power signifies your dimension. I hope you have learned a lot today, and good luck on all your work.